prove two triangles are similar using the angle-angle criteria. So let's take a look at what that is. So recall, right? Two triangles are similar if all corresponding angles are congruent and all corresponding sides are proportional, right? This is the idea of similarity. This is for triangles. So to prove two triangles are similar, the angle-angle criteria for similarity, if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So all we need to prove for two triangles to be similar is that two angles are similar, right? So this is proofs like kind of like what we did with congruence, where we did side, 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 side angle, side. We only need here to prove two triangles to be congruent that two angles are congruent to each other in each triangle. So let's take a look at what that really looks like, right? So let me get a triangle up here. Let's say we had this triangle. Why do we only need two angles? Why don't we need three angles, right? That's really what the question is. Well, if I had this triangle, right, and then I took another triangle here, I made a smaller one that looks like it could be similar. Make that a little bit smaller so you can tell. All right. And I said, okay, well, in this triangle, I've got 70 degrees in this corner, right? And in this triangle, I've got 50 degrees in that corner. And over here, I had 70 and 50 as well. How do I know, based on angle-angle similarity, that these are going to be similar? Well, if you think back to the angle sum theorem of a triangle, there are 180 degrees in each triangle. So really we only need two angles, because if we know these two angles, we know the third angle, right? Because 70 plus 50, right, is 120, and 180 minus 120 gives you 60. So this top angle here has to be 60, and so does this top angle here, right? So that's why we only need angle similarity, because if we have two angles, we need to, or we do know, the third angle based on our angle sum theorem. So it's not hard for us to get that. So that's why we have angle similarity as opposed to angle similarity. You only need two angles of one triangle to be congruent to two angles of the other triangle, right? And that's because we can add those together to get 180 and get us that third angle. All right. So that being said, let's get into a proof. So it says in the diagram below, right, or in the diagram shown, it says QR is parallel to NP. And in the previous videos, I told you just take my word for it. These are similar triangles, but today we're actually going to prove why they are similar. So it says prove that MQR, this small triangle, is similar to MNP, that bigger triangle. Well, if you think about it, these are parallel lines, right? So we always talk about what do you think about with parallel lines? And you think about a couple of things. One of the things you might think about is, okay, well, parallel lines have the same slope. Another thing you might think about is alternate interior angle theorem, right? That AIA theorem that we so heavily discussed. Okay, and that means that this angle in here is congruent to that angle there if these lines are parallel. Another theorem that you think of, right, or another set of angles is corresponding angles. And what that means is that angles that are in the same relative position are also congruent. So if we're looking at these guys, right, as our parallel lines, we can look at this line as a transversal, right? And if we're looking at this line as a transversal, we know that these two angles are corresponding. And if they're corresponding, it means that they are congruent. And then we can come to this side, and we can also use these two angles, right? And since these are parallel, these are also corresponding, and corresponding angles are also congruent. Okay, and the last thing that we could have done is say that, well, isn't M in both of those triangles? Well, yeah, it is, and that's reflexive property. So we can use any combination as long as we get two, right? Remember, two, all we need is two angles to be congruent to each other and corresponding. So let's take a look. So, well, given, right? Given QR parallel to NP, right? And we can say with MN as, I'm going to write it up here, transversal. As a transversal, we know that MQR angle MQR is congruent to angle MNP. MNP, right? Because they're corresponding angles, right? And I'm just going to write corresponding, but you'll write, I'm going to write CA, you could write corresponding angles by the definition of corresponding angles, right? That definition. Okay? So it's a little bit sloppy because I'm using the mouse, but hopefully you're following along. All right? So now we only need one more. I could do that same thing for the other one, or I can say, okay, well, actually, angle M, right? So angle QMR, which is the small triangle's M angle, is congruent to angle NMP, right? And that's the big triangle's M angle because they're both in there, right there, right? This is in the small and it's in the big, right? Are congruent by that reflexive property, okay? That reflexive property. Okay? And now, based off of all of that, right? So we've got angle here, congruent to angle there, and angle here, congruent to angle there. We've got our angle, right? So based off of that, we can say triangle MQR is similar to triangle MNP by angle similarity. Theorem. You can say angle similarity theorem. That's fine. Or, yeah, criteria for angle. Okay? So you could have thrown this other one in there if you wanted to, but I just wanted to show you that you could do it with two things here, right? So this is parallel lines cut by a transversal. This is reflexive property, and both of them get you two angles there. Okay? The next piece, well, we've just proven that they're similar, right? So if we know they're similar, we know their sides must be in proportion to each other. So let's take a look at their sides. Well, they said MQ is 8. They said NQ is 6, so I know that this whole thing here is 14, okay? And then it says NP is 21. Well, they want to know QR, what's X? So I'm going to go 14, right, over, we can say 21 is equal to 8 over X, and we're going to get 21 times 8 gives you 168, and then divided by 14 gives you 12, and X is equal to 12 there. All right, so once you've proven that they are similar, which we did here, right, by angle similarity, you can then use the idea that similar triangles have proportional sides and get those sides, or get whatever side you're looking for, by using the same proportion or the same ratio. So this is the one question that you guys have for classwork or for homework, and I just want to kind of go over it so you're not super stuck. And if you are, you can always email me and we'll Zoom. But here it says ACB and AED. So they're already giving you one angle. All you got to do is find another angle. So look at how I found angles here. Or think about how else you could find angles. Look at the triangle, see if any angles are shared there, and that's how you're going to prove it. They've already given you one. You got to find one more, and you're going to prove by angle-angle similarity that those are congruent, okay? That's all you're going to be doing tonight. All right. Thanks for tuning in. It's Mr. Pinto.